Hello, everyone. My name is Himan Namdari, and today I'm going to present a review of soil horizon. And if you're not familiar with the concept, the soil horizon is basically means the uh, sort of like the structure of the soil beneath our feet and the number of layers that it represents. So starting with the topsoil layer, we encounter the organic horizon, which is playing a fundamental role in the overall health and functionality of the soil. The first one could be edge horizon. Mostly the edge horizon can exist in some certain environments, such as bogs. It's saturated with water for the most of the year, and it's generally rich in mosses, particularly different type of mosses. The mossy content gives the unique texture and coloration. On the other hand, the O horizon, as you can see, that can vary between 0 to 2 inches, sits right beneath the surface litter, like fallen leaves and branch. It's composed of decomposed organic residuant, primarily leaves, twigs, and other plant material. These decaying material provide a valuable source of nutrition for plants and microorganisms. In essence, the O-horizon is the nature composite pile, continually replenishing the soil with essential organic matter. So wherever we get the organics, it's going to basically flow down to the other layers. So we talked about the edge and the O horizon, and here's an image representing the O horizon mostly, but you can see a slightly layers of edge horizon in this image. The edge horizon, as we mentioned before, is saturated, but the O horizon is not saturated, and it's basically formed by organic residual. Next, we have surface and subsurface, and we call them A and E horizon. These are beneath the organic layer, often referred to as topsoil. This horizon is a critical zone where biological activity is most intensive. It has blended mixture of organic matter and mineral, resulting in a dark coloration, as you can see, that indicates the rich nutrition content. The presence of humidified organic matter combined with mineral makes this layer essential for plant growth specifically, providing plant with essential nutritions and medium for root expansion. As you can see in the image, we can have some roots in the A horizon. Under E horizon, we have E horizon. This layer is characterized by the process called alluviation, where minerals and organic matter are leached or washed out, usually by downward water. So if you have any organic matters here, it will be leached out and, basically washed out to the lower layers. The leaching gives the E horizon a distinctive lighter coloration, as you can see, compared to the A horizon. Due to the loss of mineral, especially as loss of iron and clay. The E horizon can often appear pale, and it's sometimes referred to as the zone of leaching. This process of leaching ensures that the certain mineral and nutrition are transported deeper into the soil, potentially benefiting the layers below. So after this, we will have the B horizon, commonly known as subsoil. It has been indicated with a different color in here. So we can have H, O, A, and then we have B horizon. As a critical subsurface layer, it bears witness to substantial transformation from the original rock material. And over the time, the process of weathering along with the downward movement on water from the upper layer transport mineral and nutrition to this horizon. As a result, B horizon frequently exhibit accumulation of clay, iron oxide, and as you can see, it has a little bit of like reddish color here, and other minerals in phenomena called elevation. The presence of these accumulated material often impact the distinct color and texture of the B horizon. The concentration of iron oxide can give the layer a reddish brown hue, which is emphasized in the picture. It also serves as a reservoir for water and nutrition, providing plant with extended access to these vital resources, especially during the dry period. Its dense structure also acts as a supportive layer for the topsoil, maintaining the overall stability and integrity of the soil profile in general. So in dry season, the B layer is basically maintaining the most of the water. Now we are moving deeper to the sea horizon, which is closer to the original parent material, which is the layer below this, and we talk about it later. This layer is basically a transaction zone between the soil profile above and the unaltered parental material below. Unlike the layer above, the sea horizon has undergone little to no pedagonic process, which are the suits of chemical, biological, and physical action that transform and develop the soil profile over time. The pedogenic processes are essential for soil information. They include activities like organic matter decay, which is mostly happening in the sea layer, and basically mineral weathering and the movement of accumulative of material within the soil. For instance, in upper zone, the decay of organic matter can release nutrition, as we can see in A and B, while the leaching process can transport these nutrition to the deeper horizon. So this is basically transporting these nutrition to deeper horizon. Simultaneously, weathering of rock can release mineral into soil, enriching its composition. So if water reaches to these like parental material, it will actually send some nutrition to the top layer. Although while we are checking the sea horizon, which is resembles the original rock, or that the rocks that are heavily weathered, so decayed basically, the sea horizon retain characteristics that are more of the original rock or sediment which the soil has formed, offering a glimpse into the soil geological history and the material that initially gave rise to the soil profile. So again, the sea horizon can also be considered as a historical point of view for the top layers. Then we have R, I, L, and W layers. The R is basically the hard bedrock. As you can see, this is an example of hard bedrock and R layer. Then we have I's, and then we have sediment in water, and eventually we have a water table or water layer. And adjacent to the bedrock, especially in the cooler climate, we might encounter an eye layer. So the eye layer doesn't exist anywhere. It's basically will form where we have a cooler environment. These formation contains at least 75% ice by the volume, distinct by separate from other soils. The L layer represents the sediment deposit in a body of water. This layer is a testament to periods when the area might have been submerged underwater, either due to the natural water bodies or floating events. Lastly, the W layer are essentially water layers within the soil or layering submerging the soil. This can either be permanent, so as like shallow lakes or cycles. Their presence offer insight into the water table level, drainage capacity of the soil, and also indicate the potential for soil saturation, which can have implication for agriculture, infrastructure development, and natural vegetation. So these were the layers that we talked about, and now I want to talk about the application of soil horizon, why we do know we do need to know about the soil horizon in general. In agriculture, the soil horizon can determine and in different crops required a specific soil condition for optimal growth. So by analyzing the soil horizon, farmers can determine the depths of the topsoil, A horizon, its organic matter content, and potential drainage issue, which can be suggested by the presence or characteristic of the B or C horizon. So in agriculture, the most important layers are A, B, and C, just because the vegetation can penetrate up to C layer. In the civil engineering and infrastructure development, we want to know before constructing any structure, it's crucial to understand the soil profile to ensure the foundation to be stable. So the presence of certain horizon can suggest a potential for soil shifting, expansion, or concentration. So in civil engineering, it's basically a deeper layer, layers after C, layer that is most important just because it's provide a foundation for stability. In environmental conservation and land restoration, it's important because after mining activities, deforestation or urban development require a true understanding of the soil profile. It helps the conversations that basically helps to sort of like preserve the native vegetation and ensure long-term ecological balance. So for environmental conservation, it's really important. All of the layers can be analyzed to just make sure that the nourishing environment has enough nutrition to for the vegetation to grow. The conclusion and the importance of soil horizon, it's basically will influence the water movement, the root growth in vegetation, and understanding the concept of soil horizon can aid us in better performance in agriculture process, construction process, and also environmental conservation process. Thank you so much for your time. I hope that this video can help you to understand the soil horizon better, and hoping to see you in the next video. Thank you so much and have a beautiful day.